Hello, and welcome to Mrs. Law's class. In this lesson, I'm going to show you how to identify infinite geometric series, how to derive the formula, and then how to apply the formula for the infinite geometric series. All right, so let's start with this problem. So we have the sum. It says 2 plus 8 plus 32 plus 128, and so on. Does it have a value? Well, because the numbers keep increasing, we can see that this would not have a value because it would go on to infinity. So no, the sequence of numbers keeps increasing. All right. Another way to think of it is that the ratio is greater than 1, so it's going to keep increasing. Now, when we take a look at the second sequence, or second series, I should say, we have 512 plus 128 plus 32 plus 8, and we can see that the numbers are decreasing. So does this series have a sum? And this answer is yes. And that's because the sequence is decreasing. Or we can also say that because the R value is less than 1. Now, if we look at the formula for the geometric series, which I've written right here, we can see that we have in the numerator T1 times, in brackets, 1 minus R to the n, all divided by 1 minus R. Now, knowing that this ratio has to be less than 1, now it could actually also be greater than -1. So as long as it's a number between -1 to 1, we can see that as n increases to infinity, so that's this part over here, okay? So imagine that we have a half, that's our R value, and our n increases to infinity. So as n gets bigger and bigger and bigger, as we multiply this fraction half by itself many times, this R to the n value will approach 0. And you can try this out on your calculator if you like. So if you go half times half times half, you'll see that the number gets smaller and smaller. So knowing that R to the n is approaching 0, that means we wouldn't have this number here. So then we would have 1 minus 0, which is still 1. So in the numerator of this formula, we now would have t to the 1, or t sub 1, all divided by 1 minus r. And this is the sum, and for n, where n is infinity, meaning that we're going to have an infinite number of numbers in this series. So T1 stands for our first term, and R is a common ratio. And you can see that this formula is probably the easiest one out of all the ones that we've taken a look at. All right, so let's apply this formula. All right, so find the sum of the series. So we have this first one here. We can see that the first term is 12, and our ratio is 6 divided by 12, or 3 divided by 6, but it gives us a half. So we can say that the sum of this infinite series, geometric series, is 12 divided by 1 minus a half. And we can even do this by hand. So it's 12 divided by a half. And 12 divided by a half is 24. And that is the sum of this infinite geometric series. All right, you can try B on your own. So I'll call this your term. But let's take a look at this one for part C, because it doesn't have the whole sequence written out. So what we're going to have to do is we're going to use the sigma notation. So we can see that we start with k equals to 3. So we need to find out what our sequence is. So k equals 3. So we have 4/3, and that's going to be 1 minus 3. So that's going to be -2. So -2 means we're going to flip our fraction so that we can get +2 as our exponent. So this will be 9 over 16. Okay, next we have k equals 4. So we have 4/3 to the power of 1 minus 4. So this exponent is negative 3. To make the exponent positive, again, we flip it. So it'll be 3 over 4 to the power of 3. So this will be 27 over 64. And let's do one more for good measure. So we have 4/3 to the power of 1 minus 5. So exponent is negative 4. We flip. So 3 to the 4 is 81. 4 to the 4 is 64. All right. So from here, we are going to find that our first term, we can see is 9 over 16. That's our first term here. And then our ratio, let's take 27 over 64, and we're going to divide that by our previous term, which is 9 over 16. So we're going to go 27 over 64. Division becomes times 16 over 9. And we can reduce here. So 9 goes into itself once, 27 3 times, 16 goes into itself once, and into 64 4 times. So the ratio is 3/4. So we're going to plug that into our formula. So S infinity equals 9 over 16, all divided by 1 minus 3/4. So that's the same as 9 over 16 divided by 1/4. Now, instead of writing it like this, it might make it easier for you to understand if you want to write it as 9 over 16 divided by 1/4, which is 9 over 16 times 4 over 1. We can reduce by 4, so we get 9 over 4. So we're given the series is a sigma notation. You want to find the first probably 3 terms just to make sure that this is a geometric sequence. All right, we're going to do one more example, and I'm going to jump to a second page as my screen has frozen here for some reason. And so we're going to take a look at example 3 here. So this is on the second page. So we have a weather balloon. It rises 60 meters in the first minute, and each minute after the first, it rises 7% less than the previous height. So what is the maximum height reached by the balloon? So we're assuming that, let's say there's a balloon, it goes up 60 meters. Okay. And then it goes up again, but not as high as before. It's going to go up 60 meters, and it rises 7% less than the previous height. So it's actually only going to rise 0.93 or 93% of the previous height. So we're going to times that by 0.93. So that would be 55.8 meters. Okay. So we can see that T1, our first height is 60, and our ratio, each height after that is going to be 93% or 0.93 of what it was before. So we assume that this is going to be infinite because this balloon keeps on going. We're not saying that there's an end. So when does it actually stop? So the first part is we have 60 divided by 1 minus our ratio. So it's 1 minus 0.93. Type this into your calculator. So S infinity is 857.14 meters. So you want to check to see if the word problem describes a situation in such a way that there is no end, and then you can assume that the series is going to be infinite. And then now, if you like, you can try your turn too, or you can wait for the class.